Okay, so for the second numeracy homework, looking at the second half of the November 2017 Unit 1 paper, picking up at question 7, but unfortunately because we're on the iPad instead of doing this with the old-fashioned compass and pencil, this is going to be a little bit peculiar, so bear with me, I'll try to explain it. But a construction question needs to be explained in class. So question 7 is construction. And construction questions are best answered in class with your teacher. So I know this is going to be covered in an intervention lesson. The diagram below shows a sketch of the existing gas pipes that run to and from Teiglin. It also shows a proposed 180 metre gas pipe which is to be laid to provide gas to Caernia. And I'm just going to highlight that. The proposed pipe bisects the angle, mathematically that's a thing, formed by the existing pipes. So we have an angle bisector, and angle bisectors have 3 straightforward steps. So the first step is that you open your compass. I would say spike here in the very corner of Teiglin and open your compass to make a mark about 2/3 of the way across the line. Keeping the compass open, swing it round and put a similar mark on the other line. Don't alter the compass, just keep it in your hand. Put the spike of the compass now in that newly made spot. So stage 2, spike the compass here on top of the red dot and allow it to swing out and draw an arc in the middle of the field where the pipe's going to go. Spike into the other dot, swing out and put an arc also in the field where the pipe's going to go. The crossing point of these is going to create for you the angle bisector and the layout of where the pipe will go, making them the angle half above and half below, so chopping the angle into 2 equal portions. So I'll run through that again on the actual picture in a moment, but those 3 steps with the black compass markings and then the red compass lines, you would need to practice with the compass. Interestingly as well, it tells us here that it's 180 metres of a gas pipe, and the scale here says that it's 1 centimetre for 20 metres. So every 20 metres is going to be a centimetre on our diagram. So that's going to be 9 centimetres on our picture. So once you've decided where you're drawing the line, you may need to make sure that the line is then 9 centimetres long. So here we go again. Okay, stick the compass, the pin of the compass into the corner Teiglin. Swing it to give yourself a pair of arcs, one on the top line, one on the bottom line. Keeping the compass exactly the same, not altering the openness of the compass. Stick the spike of the compass here now at the top and swing out. Spike the compass on the other red dot and swing out, and you will have a crossing point. Where those 2 points cross, that's going to give you the straight line that's called the angle bisector. That's going to tell you where your angle is chopped perfectly in half. We need to make sure that our line is the right length, 9 centimetres to be precise. So ruler on here and chopping off that line 9 centimetres in, which represents the 180 metres that they talked about. So compass and ruler, but you're not allowed to use a protractor. So even though they tell you that they're chopping the angle in half, you're not allowed to use a protractor to figure out where that would be. Question 8. With a numeracy paper, the questions can be quite long-winded, and you've got to do quite a lot of thinking and not much writing or much actual maths. And this is one of those questions. So I've got to really have an idea of what these graphs are showing me and what this question's about. But on this page, there isn't actually a question. All of the questions are on the other page. In the exam, this would open up as a full double spread, so you'd have the information right next to you when you come to do the question. So looking at question 8's diagram. Ysgol Fron Isa and Ysgol Caiwen are 2 very different high schools. One is large and in a rural area. So one is out of town and a big school, and the other one is a small town in a school. The town in which the small school is situated has many traffic-free cycle routes, so cycling will be really popular in the town. All of the pupils in 7 to 10 were asked in both of these schools, and they were asked, do you cycle to school, yes or no? And if you answer no, would you like to, yes or no? And I can see these are 100 bars, because for both of them they have been done as a percentage, and then I can see they're into 3 categories. You've got a cycling category, would like to cycle, or the other, and it varies from class to class and from school to school. Okay, what's the question? Part 1. Which school and year group has an approximately equal split between the 3 categories? Cycling, would like to, and others. So let's have a look. An equal split. Which school and which year group has an equal split? Well, I can see that out of all of the bars broken into the 3 portions, the one that appears to be equally split would be this bar here, highlighted in yellow, and that would be year 10 in Ysgol Cynwen. So school, Ysgol Cynwen, and year group, year 10. Part 2 is a series of true or false questions. So there are definitely more pupils in Ysgol Fron Isa who cycle to school than Ysgol Cynwen. Well, these are percentage bars, so they might tell me how the cycling and not cycling is broken down into different amounts of pupils, as in 20% or 10%, but there's no mention of a total. So I can't actually tell you if there is definitely more pupils in one school or the other, because I can't tell you what the totals are. So that one's false. Both schools have pupils in each year group with no interest in cycling. Both schools have pupils in each year group who have no interest in cycling. Yeah, I'd agree. Each one of these bars has a portion of people who are not interested in cycling. So that one's going to be true. Part 3 of the table. The questions asked were biased. Biased questions would be leading. They would give you an idea of the right or the wrong answer. Using a bike is good for the environment. Do you use a bicycle to get to school? Something that make you feel that saying yes is better than saying no. So leading you to give one conclusion or the other. And in these questions, there's nobody leading you. They're just simply asking yes or no. It's not about opinion. It's not about what you think. It's just asking you. So completely false. These are not biased questions. They are just questions. Approximately 20% of the pupils surveyed in Ysgol Cynwen cycle to school. So approximately 20%. I can see here that for those 2 bars it is exactly 20%, and then these 2 bars, if I average them, would come up to 20% and come down to 20%. So I'd agree. I'd say yes. From looking at that diagram, approximately 20% of the pupils cycle to school. And the last one, it is more likely that the Ysgol Fron Isa is the small school situated in the town. Well, they told me here that the one in town has lots of cycle routes, and I can see when I compare them that Fron Isa has far more pupils cycling to school than Ysgol Cynwen, which makes me believe that these pupils would be using the cycle tracks compared to these pupils who are using the country roads. So I would agree, and I would say true. Okay. In 2011, there was 1,200 miles of cycle track, National Cycle Network, and in 2016, there was 1,400 miles of cycle track. If the number of miles of the routes in Wales were to continue to increase by the same number of miles per year, how many miles of cycle route would there be in 2018, 2 years after the last time they measured? Well, from 2016 to 2011 is a 5-year gap. So over those 5 years, they managed to secure an extra 200 miles of track. So if they continued on a similar rate, not necessarily likely, but if we say those 200 miles was spread evenly over the 5 years, then that would make us believe that they did 40 miles of track each year. So by 2018, 2 years later, they would be the 1,400 we've already got here, and another 2 years worth of cycle track, making it 1,480 miles. Why is your answer in part 1 unlikely to be accurate? Okay, so this is what I was thinking, and I'm glad they've asked. Why is it unlikely to be an accurate estimate of the number of miles by 2018? This 200 was the total for the 5 years, so the number each year can increase or decrease. The average was 40 miles per year, but that's not necessarily going to stay the same. We don't know what will happen. Cycling is becoming far more popular, so perhaps the amount of cycle track run every year will increase. Or in the other way, they could run out of money and there might be not any more cycle tracks for the next 2 years. Any of these answers will give you the extra mark. So I'm simply going to write, don't know what will happen. They may run out of money. We can't tell. Okay, so any logical explanation will give you that extra mark. This is an E1 mark, so for explanation, for being able to come up with a logical reason. Okay. Question 9 gives us a conversion graph. William owns and runs dog kennels, and his costs depend on the number of dogs in the kennel. Here are the running costs for 1 day. Okay. Part A of the question says, why does the graph not pass through 0, 0? 0, 0 would actually indicate that if there are no dogs in the kennel, William doesn't have to pay anything, which wouldn't be true. So even if there's no dogs in the kennel today, he's still got to pay for the mortgage, he's still got to pay for electricity, he's still got to pay any of the bills that don't rely on feeding or walking or doing anything with the dogs. So he still has to pay his fixed costs. He still, this is another E1, logical thinking, still needs to pay all fixed costs. And I'm going to give an example, electricity. So he's got to pay for that even when there's no dogs staying at his kennel. Part B, what is the increase in the daily running costs for each extra dog? So we need to know the gradient, the steepness of the line, to know how much increase we have in the cost. This will be the cost dependent on the number of dogs. So the easiest way to deal with that is to make for ourselves a right angle triangle. So that right angle triangle, I'm going to make it from the 50 to the 250 to give myself Nice easy numbers to work with. I can see that the change in height here on my right angle triangle, if I go from 50 to 250, is 200. So that's an extra £200 that I've had to pay. And I can see that the number of dogs that this right angle triangle works with, between 60 and 10, would be 50 dogs. So £200 for 50 dogs. So back over here, I have £200 shared out between looking after 50 dogs. This will give me how many 50s and 200? £4 per dog to look after them. Part C tells me Frida also runs a dog kennel, and the cost of keeping 20 dogs for Frida is actually going to be £130. But she knows that as the number of dogs increases, the overall cost increases at the same rate. If they're increasing at the same rate, they would have the same gradient. They would be what we call parallel. So we have a pair of parallel lines, but we do know the 20 dogs is £130. So find that point. 20 dogs, 100, 110, 120, 130, 140 and 150. So here's 130. So if I go across, 20 dogs and 130 gives me that point there. But we know that as one increases, so does the other. So my line that I need to draw will be parallel to the line that we already had for William's kennel. So now it's drawn on the graph. Okay, so that's Frida in Frida's kennel. The last part, I'm just going to write there drawn if you're looking for the answer, is on that page. The last part, find the cost of keeping 30 dogs in Frida's kennel. So I've got to use that new black line now. So 30 dogs come up, hit the line, come across, and 30 dogs is going to cost us 150, 160, £170 to keep in Frida's kennel. Okay. Question 10. Marion's window cleaning business. No job too small. Marion is a window cleaner. From Monday to Friday, he records how long he spends cleaning windows for each of his customers, and he draws this cumulative frequency diagram to display the findings. He's got 120 customers, and altogether we're over time, which is 25 minutes. So again, like before, no question on that page. You just need to have an idea of what information you're given, and the questions are on the other half of the double spread. Use Marion's cumulative frequency graph to find the median and the interquartile range for the times that he spends cleaning windows for each of his customers. Okay, so we're back to the diagram for the median and the interquartile range. So the first thing we need to do for the median is find the middle of our cumulative frequency from 0 to 120, which would be 60. Go across the graph till we hit the cumulative frequency curve and down. And we can see that for the median, that piece of information comes out as being not 15, not 16, but 17 minutes, pardon me. So median, 17 minutes, halfway up the cumulative frequency. And then for the interquartile range, I'm going to need to look twice at the graph, and I'm going to have to do the upper quartile, take away the lower quartile. So looking at the graph this time, I've got to go for the upper quartile and the lower quartile. So halfway between 60 and 0, go across at 30 and go down. Halfway between 60 and 120, which is 90, go across and go down. So this time my lower quartile and my upper quartile, lower quartile, upper quartile, also taken from the graph. So we have 10, 11, 12, 13, 14, 15, 16, 17, that was the median, 18, 19. So these two are my quartiles. That's the lower one and that's the upper one. And the interquartile range is the gap between them. So the interquartile range is the gap between that 19 and that 14, which gives me an interquartile range of 5 minutes. So the interquartile range is 5 minutes, and that's going to come from, like I said, 19 minutes for the upper quartile, take away 14 minutes for the lower. Part 2. Myrion looks back at his raw data. So he's looked back at all the numbers he had when he was doing the actual window cleaning. He finds that the median is actually 17 minutes 30. Why is this this difference between the one off the diagram and the actual raw data? Well, raw data is always more detailed than the graph. The data is being grouped to make the graph, and the actual times have been lost. So we can put that down. It's another one of those E-marks to show your understanding, and you need to explain the raw data is more detailed, and now the data has been grouped. So the actual times have been lost. And that's definitely one good mark. Part B. Myrion is looking at the times it took to clean individual customers' windows. Find the number of customers that it took between 10 and 15 minutes. So as I go back to my graph now, I'm actually going to clear it so that I can look at this fresh and without any earlier lines to confuse me. So if I'm looking for the customers that took between 10 and 15 minutes, as I look at this cumulative frequency graph, I'm going to focus on 10 and 15 minutes. So up to 10 and across, that's telling me 10, 11, 12 customers, and up to 15 and across, and that's telling me, where are we now, 30, 32, 34 customers. So looking to see between 15 minutes there was 34 customers, and between 10 minutes there was just 12 customers, and if I'm going in between that, 34 take away 12 gives me 22 of his customers that are between those two times. Myrion thinks that for approximately 80% of his customers, he's cleaned his windows in less than 20 minutes. Now Myrion's got 120 customers, so 80% of 120 would be 8 lots of 12, 96 customers. So let's have a look at the graph to see if for 96 of his customers he's in less than 20 minutes. So if I come over here, and there's the cumulative graph, I'll change the colour of the pen so that you can see it from the other one. 96 of his customers, there's 90, and then there's 92, 94, 96. 96 of his customers would be that green line, and if I come down to the bottom here, they actually come in at 19 minutes. So my conclusion, you must show your work in so you can have a look at the graph. 96 customers, on cumulative frequency graph shows, I forgot what I showed. Have another look. 15, 16, 17, 18, 18.5 minutes. So shows less than 20 minutes. And what you've drawn on the graph along with your explanation will get you the marks. Okay, the readings on the graph will be acceptable for the method marks. Turning over for question 11. Another page of information. Quite a heavy piece of information here about electricity bills. Electricity bills are worked out automatically in real life, but on here we have an electricity bill that shows us the previous meter reading and the present meter reading, and this figure here is just the difference between the two. Charge for electricity is done in pence for every unit. So for 450 units, they've done 450 times by 20p and then turned into pounds. Standing charge is for a number of months and it's a price per month. So that's 3 of those. And the total then has 5% added on to get the grand total for the bill. So there's quite a lot of maths involved. To start off with, part A, the charge for electricity has increased by 5%. What is the increased price? It used to be 20. So for a 20 pence charge, 10% would be 2p, 5% would be 1 pence. So the new price has gone up by 1 pence. It's now 21 pence per unit. Part B tells us a lot more information. Megan wants to work out the next 3 monthly bill. Her meter reading was 14,400 compared to 13,900. So she's used 500 units of electricity. The charge for electricity was increased, so it's really 21 pence, not 20. And the monthly has gone up by 20 pence. So it's not £7.60 anymore, it's going to be £7.80. Or it's this with an extra 3 lots of 20p for the extra on top of it. And VAT is still at 5%. Once we've worked out how much she has to pay in this 9-mark question, we've then got to see, has she got enough money in her bank, 470, to pay this bill and buy a washing machine? Wow. Okay, so let's get that little bit out of the way. First of all, she's got 470 in the bank. And if she bought a washing machine for £330, this means that she's only got £140 to pay her bill. So as long as the bill comes in as less than £140, we're okay. If it comes in as more, we're not. Like I said, she's used 14,400 units compared to 13,900 last time. So in these 3 months, she's used 500 units of electricity, and they are now going to cost 21 pence each. So 500 lots of 21p, 5 21s are 105, 00 on the end, but that's in pence. So she's going to have to pay £105 for her electricity. But she doesn't just pay for the electricity. just add in some details here so that you know what's going on. Budget, £140 to pay a bill. Electricity is going to cost her £105. But my next heading is standing charge, because she's also got to pay that for the 3 months of having the electricity from the company. So it was £7.60 plus an extra 20 pence that was mentioned down here. So £7.80 for 3 months, £22.80 if it hadn't gone up, an extra 60 pence because it had. So the standing charge was £22.80 plus an extra 60 pence because it's gone up. So the standing charge is now going to be £23.40. The total between the units and the standing charge, £105 and the £23.40, is going to come in at £128.40. Still not done, I'm afraid, because on top of that now we need to add the VAT. VAT is at a 5% level. It says over here 5%. So we've got to work out 5% of our £128.40 and add that on and hope that it comes in under that £140 that she's got left to pay her bill. This is a 9-mark question, but the maths isn't that difficult. You've just got to follow the story. So 10% of our £128.40 would be £12.84. 5% would be half of that, so £6.42. The final total that she has to pay for her electricity is £128.40 plus the £6.42, which comes to £134.82. And at the very beginning, we said she had £140. So we need to say she can afford to buy, a new washing machine. Yes, she can afford to buy the new washing machine. Because she's actually going to have £5.18 left over when she's paid the bill and for the washing machine. But that whole page isn't very difficult maths, there's just a lot of it. So that 9-mark question does need another look. We have, at the beginning, the budget. Take out the price of the washing machine, we know she's got £140 left to pay a bill. Work out the electricity, working with the 21 pence per unit, changing from pennies to pounds. The standing charge has to be worked out, but they charged you extra 20 pence every month and there was 3 of them. The total of the bill is still not the end, because then there's that VAT that needs to be added. My final price for my electricity is £134.82, and I had £140 to pay the bill, so I'm okay. Question 12. These are box and whisker plots. A box and whisker plot is based on 5 important numbers: minimum, maximum, lower quarter, upper quarter, median. Minimum, maximum, lower quarter, upper quarter, median. Those 5 numbers are used to make those 5 lines, and then the middle 3 make it into a box, and the other 2 go as the range. The range is the maximum take away the minimum. The interquartile range is the upper quartile take away the lower quartile. So the difference between the top end and the bottom end of the box. Okay. Question 12. First of all, I don't have a question here. I've just got 3 diagrams. It's talking about the width of an apple. This apple over here. And she's picked 50 apples from each of the 3 trees, and we've got Gala, Orange Pippin and Pink Lady. Alright, filling in the gaps. Complete the following statements. Apples from which tree have the least median width? So the least median. The median is going to be the middle of the box. So I'm looking for the least, the smallest, and that's going to be orange pippin. So orange pippin. Double P, pardon me. Orange pippin. The median width of apples recorded for this tree is orange pippin here, 50, 55, 56, 57. The range of the widths of apples recorded for the Gala apple tree is, so we're talking about range, and the range for the Gala apple tree is, the range is the difference between the maximum and the minimum. So this one's pointing at 42, this one's pointing at 83. 83, take away 42, makes 41. So the range would be 41 millimetres. The last ones now, part 3, the something apple tree has the greatest interquartile range. The interquartile range is the spread, the width of the box. So which ones have the greatest interquartile range? The biggest box. And the biggest box, as you can see from the diagram, is going to be the pink lady. The pink lady apple tree has apples with the greatest interquartile range. The interquartile range of the widths of apples recorded for this tree is, so if I look at the top of the box, 79, the bottom of the box, 46. To work out the interquartile range, 79, take away 46. And that's going to give me 33. Which tree has the highest proportion of larger apples? You must give a reason for your answer. Highest proportion of largest apples. The median, don't forget, represents the 50% mark. So 50% of the Gala apples are above 62. 50% of the orange pippin apples are above 57. But 50% of the pink lady apples are above 64. So in answer to the question, which tree has the higher proportion of larger apples? I think it's the pink lady tree. And my reason is because it has a higher median so don't know, I'm writing there, half 50% of the apples are above 63, I believe. Half the apples are above 63. So interquartile range and median. And on that box I'm just going to plot minimum, lower quartile, median, upper quartile, maximum. Range, max, take away min. IQR, upper quartile, take away lower quartile. You need to learn these, year 11. They're going to come up in your numeracy exam. Question 13. We're looking at two photos of a beautiful tortoise. And we are told in question 13 that Emlyn has a photograph that he wants to enlarge. The diagram of the original photo and the enlargements are shown. So I can see that the length of this diagram used to be 6 and now is 15. And I've got to find the scale factor. How many times bigger did that length have to be made to make the new picture? And I know that to get from a 6 to a 15, you had to multiply it by a 2.5. So everything in the new picture has been made 2.5 times bigger. Taking that into account, my 4 centimetres for my width would also need to be made 2.5 times bigger to have the right width in my new picture. So calculate the height of my new picture. Everything is 2.5 times bigger because that's the scale factor that's been used. So the 4 centimetres is going to be made 2.5 times bigger. So the height of the new picture is going to be 10 centimetres. That's the end of the paper. And when you come to look through a numeracy paper, question 13 here is no more difficult, really, than question 8 or question 9. But the topics that it covers can be more involved. Question 13 was a 1-page question. But don't forget, questions like 12 and others take a 2-page double spread. So there's quite a lot of reading and quite a lot of information to get through. Good luck in your numeracy exam, and I hope you follow this easily. There will be more numeracy homeworks very soon.